Good afternoon, everyone. I know it's 4:01 right now, and people are still hanging out outside, but to be respectful of everybody's time here, we could start. Thanks for being here today for our session, Making AI Actionable, Transforming Earth Science Through Generative AI, Street View Imagery, and Machine Learning. I am Qian Huang, Research Assistant Professor at East Tennessee State University. This session is co-organized with Dr. Ziheng Sun at George Mason University, also the Machine Learning Cluster Chair. Speaker of today, including me, Dr. Tao Hu from Oklahoma State University and Dr. Hanling Zhou from University of Connecticut. Agenda of this session, we're going to have a short introduction about generative AI, machine learning, street view images, and we will have 3 presentations. First one is about using GeoAI to measure visual beauty development and human behaviors. The second one is about the FAIR principle in workflow, and third one will be a use case to using generative AI for automated flooding dashboard in Central Placha. That was funded by last year's ESIP Small Lab grant. Thanks for ESIP's support on this project. And we just delivered our final deliverables. However, we're continue refine that dashboard. And at the end, we'll have a small breakout session to discuss some how could you make you trust more generative AI, those big questions. So let's pass it to Dr. Hanling Zhou.
Hi everyone, my name is Hanling and I'm the assistant professor at the University of Connecticut. So let me start and continue our discussion and presentation today. So nowadays, sounds like GeoAI is a big topic, no matter that you will find that many researchers talk about it, and also in the seminars, in the a research meeting, a lot of people talk about it. And these topics can cover different parts. So for example, they include the traditional the field surveys and field work, and also include the different data sets such as the remote sensing data and the UAV data and the street view images, and also include the different parts of the AI-related techniques such as the intelligence computing, big data analysis, generative AI. And today we may just focus on 1 or 2 parts as a key example to present the powers of the GeoAI. And so by using this kind of the GeoAI techniques, so we can help assist our observations, to test our hypotheses in geographical analysis and public health, and also earth science study. And also we can try to make some predictions based on our findings to help contribute the research domains. So for example, here, this picture gives some examples that we can conduct the observations and then the hypothesis, and also to make the predictions to benefit the AIs for geoscience. So how it can be contribute? And today our research talk will give 2 demos. So the first part is that we integrate the street view images and the machine learning techniques to conduct the image processing. So for example, we can train the deep learning models to conduct the image segmentations and then use this kind of the data to study the geography problems and any kinds of the earth science data related problem. And aside from that, now we know that there are a lot of the hot topics like the generative AI, such as the ChatGPT and DeepSeek. So these kind of the agents, and they can automatically help you to give you the contextual response, so based on your given questions. And also it can be used to help you to work on the computations and different kinds of geospatial analysis. And now I give the first example to show the powers of the GeoAI to see how to make AI actionable. So this topic is to use the GeoAI to explore the associations between the visual built environment and ethic transport. So before the start of our talk, so let's to see how the previous people talk about it. The American philosopher Emerson once claimed that the first wealth is our health. So this sentence highlights that the good health is essential for the prosperity of our lives. So edit transport is one of the important domains that belongs to the physical activity during the travel. And this kind of things is one of the important health behaviors that can try to promote our health status. So based on the Canadian and the USA 24-hour movement guidelines for adults, it suggests that, well, we should conduct at least 150 minutes of moderate to vigorous physical activity per week. Well, 2.5 hours sounds not a lot, but the data show that the half of the Canadians did not meet these guidelines. So therefore, to help promote the physical activity, maybe we can try to start from our daily life, such as the active transport. So promoting the active transport can help meet this guideline, reduce the risk of diabetes and heart disease, and lower the greenhouse gas emissions and air pollution. So the traditional health geography theory highlights that the place is important for the health behaviors. So these theories that want to highlight that the place is not just a simple container that store how many hospitals, how many POIs, how many these kind of the healthcare systems within the geographical areas, but the experience of the place can also matter. So for example, how we perceive the built environment, how the built environment looks like, that kind of things can affect our decisions to conduct the health behavior, such as the active transport. So based on this hypothesis and statement, the previous scholar, they further developed the ecological model of active living. So active living, it means there's some healthy, actionable living styles, which includes the active transport. And based on this ecological model, it documents that the behavior settings and perceived environment of the built environment can try to promote the action living behaviors, such as the active transport. And based on that, we can find that the observation and the perception of the built environment can influence the active transport. So how? Here I give a very brief example. So first, we will need the walking and cycling paths. So which means that we need the necessary paths to conduct the active transport. So even though the environment looks pretty amazing, but if there is no walkable areas, so we cannot walk on that and we cannot conduct the active transport. And also the greenness is also very important, not just because the greenness can improve the air quality, lower the noise level, provide a shade, but it can also reduce our stress. So while the previous research, they have documented that, okay, so this kind of the greenness and this kind of the necessary, the walk paths and cycling paths are important. The previous research, they are limited by the data source. So traditional, the GIS and the remote sensing data, well, of course, they are great and they have been used for decades, but sometimes they are unable to capture the visual built environment from a human eye levels along the travel roads. So for example, this is an example of the remote sensing images. So we can see that these images, they capture the built environment from the sky. So, but you are not the birds, right? So you work on the environment. So you walk on the street. So usually when we perceive the environment, we will not fly like the birds and then watch the environment. So we just use our human eyes. So therefore, maybe we should think about a new data set to measure this kind of the visual built environment. And of course, aside from using this kind of the remote sensing data, we can use the surveys and observations. They are useful, but at the same time, they are costly, time-consuming, and limited the spatial coverage. So if you use the Google Scholar and search this kind of the relevant articles in like maybe 10 years or earlier, 10 years before or earlier, you will find that most of the study area, they are just limited just within a few neighborhood areas, or like some, maybe there are some very big paper, they include some big study area, but we find that it's rarely happen. It doesn't mean that they are not hardworking, but just means that it's very difficult to obtain the large-scale data analysis. So is there any possible ways to address this limitation? The answer may be yes. So this can be benefits the advance of like the relevant newly data source, the street view images. Of course, they are not new, so like I think everyone here may know what it is. So if you open the Google map and then you will find the small persons on the right, and then you drag this person on the streets and you can see the street view images. And the street view images can capture the eye level, natural and human-made landscapes. And also is cost effective for large scale analysis. So you don't need to conduct like the complex field work. What you need to do, maybe just connect the Wi-Fi and then open the browser, and then you can explore the street view images all over the world. So this is the examples of the street view images that you can access. So you can access it from a different angles. So for example, like the north, east, southwest, and the place that may look like that. And also you can use the panoramic view, but sometimes it may have some distortion that you should be aware of. And compared to the remote sensing images that capture the built environments like the bird's eyes, the street view images can capture the human eye level physical environment. And also, for example, like this is an image example in Toronto. So we will see that compared to the remote sensing images. So the street view images can capture the visual built environments on top of the bridge, on top of the highways, but can also beneath the highway. So that's the powers of the street view images. And based on that, we can define the street view images by using the three key components. First, it captures the human eye level visual built environment. And this kind of the environment usually is the physically visible environment on the street locations. So by using this kind of the effective street view images, so what we can do furthermore, so now benefits by this kind of the AI techniques powers, we can use the machine learning and deep learning image segmentation models or the image understanding models that can automatically quantify the built environment elements over the large spatial area. So for example, we can try to quantify the contents of the percentage of the greenness on the road, and at the same time, we can also compute the safety scores, like and other related perception scores. So based on that, here's as an example, I give my research questions. So now we know that the health theory, now we know that the powers of the street view images and this kind of the geo AI techniques. So how these kind of things can improve the current existing research. So for example, we want to know how are the visual built environment elements. So for example, like the road, sidewalk, traffic lines, vertical greenness, horizontal greenness, how these kind of the visual built environment elements are associated with the duration of MVPAs in active transport. Well, to start this, sounds like this is not a very big question, but to achieve that, it still need a lot of work. So first, I conduct the university ethical reviews to get the approval. And after that, I make the poster and then build the sign-up links to recruit the participants. So for the people that are interested in my data collection, they can join my orientations. And after that, if they want to join the data collections, so they may sign the consent form and then pick the device for a week, and then they return the device, I extract the data and then conduct the next round of the data collections. And this is the daily log of our participants. So first, this person needs to wear the activity sensor to capture the intensities of the MVPAs during their active transports. And second, this person needs to carry a GPS device to check their trajectories. And furthermore, so that one thing that we make the big improvement is that we get a daily travel diaries that is automatically detected by the GPS device. And then we use this kind of thing to get a diary draft and then send to the participant, and the participants help fill out more information. So these kind of things compared to traditional paper-based travel diaries, we can help alleviate the recording bias. So how we make these things be possible? So this is our work. So first, we use the accelerator-based GPS device. So this is not just a simple GPS device. It means that if you don't move the device will not check anything. So these kind of things can significantly increase the battery life. And once this person moves this GPS device and start to work, and this device will start to automatically check the trips. And after that, we import all the identified trips yesterday into the travel diary website. And then we message this travel diary to the participant. And then the participants can receive all the travel diaries yesterday, and then they can report the travel modes of each trip and also report the incorrect trips detected by the device. And based on that, we are able to extract the physically activities related travel, such as walking and cycling. So we focus on the participants aged from 18 to 64 living in or around the city of Mississauga in Canada. And we recruit over 130 participants. And 112 out of them complete all the surveys and the data collections. And we get over 25,000 GPS locations that were extracted from the active transport from these participants. And this is our analytical framework. So once we get this kind of the travels, and then we obtain the corresponding street view images, conduct the image segmentations by using the AI techniques, and we make the aggregation from the image level to the individual level to finally answer my research questions. And this extracts like the physically visible roads, sidewalks, traffic lights, and the greenness based on the previous literature review. And to measure the intensity of the MVPAs, so we use a duration in minutes of moderate to vigorous physical activity intensity during the active transport checked by the activity sensor. We also make this kind of the data aggregates to each individual. And for the models, instead of using the traditional like the linear regression models, here we use the negative binomial model. It is because we can see that this is the distribution of our dependent variable, and it is right skewed, and which means that the outcome variable has the over dispersion. And the negative binomial model is relatively powerful to address this kind of the over dispersion compared to the traditional linear regression model. And based on that, we make three models here. So first is just the basic models without any elements derived from the street view images. And then we add the model with this kind of the variables. We further make the greenness from these street view images more specific, including the horizontal and vertical greenness. And to evaluate the model performance, we use the AIC. So this is parameters that to compare the model performance. Usually, if the AIC deductions is over 2, it means that adding these variables has a better performance. So this is the model result. So we can see that first, before using the models, building the models, we test the multicollinearities, and all the VIFs are much lower than 10, and it's not a big problem. And also the AIC reduction is over 2, so which means that adding this kind of the street view related visual built environmental elements can help improve the model performance. And among these variables, we will find the roads and vertical greenness and make the positive associations, while the traffic lines make the negative associations. I just highlight the key variables here, but I mean, we should acknowledge that we also include many others, the control variables inside the model, but just not list here due to the size of the PowerPoint. And based on that, we can quickly draw the conclusions, is that by using the integrating diverse data sets, so this study provides a more accurate and objective spatial temporal measurement to understand the association between the built environment and active transport. So to promote the active transport, we can conduct some built environmental interventions. For example, we can make more consecutive paths, so such as the paths with less traffic lines to stop the bicycling and walking. And also we can add more greenness. But it should be acknowledged that the traffic light here, they can be the confining factors, which can be related to the population density. And future research needs more attention and more research to improve and find the interior connections between the traffic lines and population density, as well as the active transport. And this is a key reference for these parts, and this is a demo and examples that demonstrate the powers of GeoAIs and how this kind of thing can contribute to the health research by using the earth science data. And next part will be presented by the Dr. Who's online. So Dr. Who, can you hear us? You're ready?
Yes, I can. So could you hear me well?
Okay, I may stop sharing. I think you can stop share. You can share now.
Do we have any questions? Or any questions?
Yeah, thank you.
I know it's quite late
Let me
for
share my screen.
people, like 7 something right now. I know it's super late,
Can you see my screen?
but do we have any burning questions right now?
Yes, we could see your screen.
All right.
We're waiting for a couple of questions, though.
Yeah.
Can you hold on a
No
second?
problem. Yeah.
Okay, we can always
Yeah, we
save
can.
our question to the end. And Dr. Hu is gonna present his work around the FAIR principle in workflows.
Okay. All right, so we'll start. Hello, everyone. Thank you so much for joining this session. And my name is Tao Hu, currently at Department of Geography at Oklahoma State University. And my topic today is FAIR principles in workflows, an AI-enhanced GeoScience workflow management system for reusable, reproducible, and replicable studies. So actually, this kind of work is partially funded by an NSF project, which aims to understand the disease dynamics in Oklahoma. And in that kind of project, we have a couple of PIs and co-PIs, and it's kind of diverse team. We have PI co-PIs from mathematics, geography, and social math communication, as well as history and geography. So in such a diverse team, how to make or each experts from different trainings can easily reuse, reproduce, and replicate others' research is a kind of question that we want to address. And actually, the reproducibility and the replicability has been mentioned. And a couple of years ago, actually, it's 2015 in ASF, there was a report. In the report, they have a clear definition of these two terms. So the big difference between the reproducibility and the replicability is that the reproducibility is using the same material and procedures when they try to replicate previous studies, and replicability indicates trying to duplicate the results of prior study using the same procedures but the new data. So the big difference of these two is replicability is using new data, but reproducibility is using the same material and procedures. How to conduct reproducible and replicable research is quite challenging. Back to 2016, Nature has been conducting a survey. In the results, they found 70% of researchers have failed to reproduce another scientist's studies, and around 50% researchers have failed to reproduce others' their own experiments. And similarly, in the Harvard Dataverse, it is a quite popular use open source data repository, and they have similar findings. So in this data repository, they not only share the data sets as well as providing incorporating the third party to run the scripts and using the data in the repository. So they found when users they found that about 84% of re-execution of R script are failed. And the main reasons including working directory errors and could not find the functions and package and library errors and so on and so forth. And in addition, I also summarize some other the main reasons to lead to the failure of the reproducible and replicable work. The first one is unavailable and scattered data sources. The second one is inconsistent environments such as different operation systems, different computing environment, and the availability of software and versions of libraries. As you may know, that for example, Python 2.7 and Python 3.0, they have significant gaps. It is really challenging and difficult and to do the upgrade from the source code developed from 2.7 to 3.0 by Python. And the last but least is undocumented process. So many of scripts and also the codes without detailed documentations, others are kind of hard to replicate the whole process. So one typical solution to make a reproducible and replicable work is a scientific workflow management system. Scientific workflow refers to data analysis pipeline to answer the scientific questions. And regarding management system, or we call WFMS, is a systemic way to streamline processes and facilitate seamless interaction between domain specialists and computing infrastructure. As you see the figures below, so it shows the basic, a flow or structure of end-to-end computational scientific process using workflow. So when we have using the workflow or workflow management system, it can accelerate workflow design and reuse based on this drag and drop visual interface. And it can also facilitate like the data and the tools as well as the whole workflows sharing and then publishing. In addition, the management system can help to schedule, run, and monitor workflow execution. And the last is to provide some kind of reports and help users to analyze the results and do some and as well as like reporting and problems analysis. And regarding like the workflow management system in geoscience, it has several like open source tools, and this is also the one that I want to focus on today is of open source tools. And we have several typical ones. The first one is Kepler, and this is a project also founded by NSF at the beginning of 2000. This one is has been developed for many years, but it has very limited like functionalities to run GSI models. And at the same time, it uses very like traditional technologies. For example, as you can see, this is a desktop-based or client-based like desktop. It's kind of workflow management system. So it's hard to like install among different kind of operation systems, and also users need to install or pre-install some kind of software and packages. And these are kind of barriers to lead to the reproducible and replicable work, especially for nowadays. And the second one is KNIME. So KNIME is open source, the workflow management system. And it's the main goal of this workflow system is to provide some the visual-based programming, like users can easily can drag and drop some kind of tools into this workspace and create workflows for data scientists. And I think a couple of years ago, like Harvard Center for Geographic Analysis, they started to build the collections with a KNIME, and they have created many different extensions of geospatial tools. So right now it has a great like functionalities to allow geoscience research, and especially for data analysis, visualization, spatial data processing, manipulation, visualization, and modeling. However, the big challenge for this tool or this platform is that it is only runnable in this kind of environment. So if you want to run like the whole workflow in the other platform, it's not durable because it's not following any kind of standard or a standard which has been used by others. And third one is a GeoViewer. So GeoViewer is developed by Zihen, and he's also here today. He's also one of the organizer. And this kind of platform is also called workflow management system, and it is basically used to leverage some machine learning and deep learning models in HPC to advance like geoscience research. But it has some kind of extent of disadvantage is because users need to have some kind of basic understanding of programming. Even though you can just simply run the workflow, but sometimes if you want to change the maybe parameters or maybe change the data sets, you still need to understand like the scripts or especially the Python script to some extent. So it also creates some kind of barriers for users without any kind of prior programming skills. And at the same time, I have a comparison with other existing open source management system, workflow management system, such as Kepler, KNIME, Galaxy GeoWeaver, Nextflow, Apache Airflow, SnakeMake, Cromwell, and I compare these kind of different open source tools from the perspective of user interface, whether it's following any standards such as CWL, which is a common workflow language, or workflow description language, as well as like scalability, reusability, interoperability, geospatial focus, learning curve, and we also have a summary of a strength and limitation here. And due to the limited time today, so I just want to make a conclusion is that so currently a lack of a geoscience focused workflow management system with a robust geospatial analysis capacities that is reusable and shareable across different platforms and accessible to users of all experience levels. So how to like address this big challenge or the limitations within the current workflow management system? And we propose to follow this FAIR workflow. I believe many of you are familiar with FAIR, which has been used in data in data perspective, but how we can use that in the workflow. So we can basically, we want to make our data, our tool, and the entire workflow findable, accessible, interoperable, and reusable. So based on these, it can enhance the reproducibility and the replicability of geoscience research. And this project, so we have several like aims. The first one is to design a geoscience workflow management system that incorporates FAR principles throughout the life cycle of geospatial data processing analysis, and guaranteeing the interoperability and reusability of workflows by following this common workflow language standard. And third one is to improve the findability, accessibility of geospatial workflows by using open data repository and such as Harvard Dataverse for sharing workflow-related digital resources. And last but not least is to provide a prototype of such a platform featuring an intuitive workflow designer, making the creation, design, and editing of workflows accessible to end users with different levels of technical expertise. So next, I want to briefly mention the framework that we use in this platform. The first one I want to address is a common workflow language. It is an open standard for describing how to run command line tools and connect them to create workflows. I want to give an example. So we have, for example, we have a workflow. In this workflow, we have two like input. Maybe it's one data and the other is one file, the other is another file. And then we have two steps or two processes, step one, step two. And in the last, we have like one single output. So how we can define this workflow using this based on this common workflow language standard. So, and here in the middle is a workflow specification. So this is a main workflow like specification file. It defines like the inputs, steps, or the processes and outputs. So in the inputs, which defines the input, it could be variables, it could be a file, and it could be any other data types. And second, it defines like different processes. For example, we have step one, which is to run this kind of step underscore dot CWL. And step two is to run this step two dot CWL. Actually, so each CWL here indicates to a command line tool. So it can be a Python script, it can be an R script, it can be a bash script, or even the Docker image. In our example, because we want to make sure our like tools and can be run, can be reused in different kind of platforms. So we use a Docker image, so users don't need to worry about what kind of version of the Python I'm using, what kind of tools I'm using. So everything is already packed in the Docker image, so it can be easily reused by any users. And the last part is output. So we have one single output. We have data type, which is a file, and this is the space the place to save this the output. So basically, this is so once we have this main CWL specification, and then we need to use this job.yaml file, which define the locations of the input file, and then we can run this workflow using CWL tool. All right. And so here is the basic structure of our management system. So we have 4 different layers. On the top is the data layers. So we have data from different data sources, Harvard Data Version, CDC, and even GitHub and the US Census Bureaus, okay, and Oklahoma MassNet, and so on and so forth. And the second part is a workflow layer. So in the workflow layer, we have like workflow designer and using the HTML, CSS, and other like techniques. And so users can easily drag and drop the tools and to create this such kind of workflow. In the environment layer, so as I mentioned, we develop the tools based on Docker image. So each Docker image has its operation system, has libraries, and its corresponding functions. And those kind of tools can be for example, it can be overlay analysis, can be buffer analysis, or can be the crop image analysis, and so on and so forth. And then we will streamline this process and to create this workflow. And in the bottom is the execution layer. In the execution layer, we use Apache Airflow. However, because like the stable standard is kind of inconsistent with the format of for the Airflow, so we need to do some kind of conversion from the stable to DAG. And then we can take advantage of this kind of open source tool to manage and to monitor the process of workflow. So this is the main modules in our system. All right. And the next important part is that we want to, as I mentioned at the beginning, so workflow is not just about to streamline the process. At the same time, we want to take advantage of current technology, such as large language models or other AI tools to automate the process. So here we take advantage of large language models, especially the OpenAI, to build the AI agent to provide the tools and and the data and even the workflow for users. So users can just simply provide a query or provide a prompt, and then our system can give a provide corresponding tools and the data and the workflows to users. And here we just feed. So for all the data sets, all the tools and the workflows, we have metadata information. We just feed this metadata information for the AI agent. And once it has all the information, and then we use this kind of train of thought framework. So the train of thought framework can help us to improve the reasoning abilities of large language model. It can break down a very complex problem or kind of query into small and manageable steps. And on the right shows an example. So we can have for example, user have a query, find all hospitals within 1 kilometers from a flooding zone in Central Plaza. And then based on this query, we can take advantage of a chain of thought framework to split this kind of task into very small actions. Each action is corresponding to a tool, and I listed here. And so here we can have action 1 is to read the flooding data from LOA. Action 2 is buffer analysis. Action 3 is to read hospital data. And action 4 is to conduct overlay analysis. And then we can get response based on this the framework. Okay, so the last part is I'll try to wrap up quick soon. So we have a prototype, and this prototype is to create new case studies. And the case study 1 is to use our workflow to conduct spatial interpolation of environment data. So we have 2 input files. One is the county boundaries of Oklahoma. And the second one is the ground station of environment data from Oklahoma MassNet. And after that, we want to extract the information. We want to get information. We want to get the environment information at a county level. And this one is the geospatial accessibility to health facilities. We have implemented 3 tools, the E2SFCA, G2SFCA, and 2SFCA, which is to quantify the accessibility scores to health facilities. And then similarly, we have developed this kind of workflow and then to show this are the results. And the last one is accessible hospitals in flooding areas. We have integrate the satellite image processing from Google's engine. So we have provided several tools here, and it can help us to conduct the flood detection. It can from different satellite image. It can also retrieve the hospital data from the CDC, and then we have this are the processes. We have limited time here, so I just want to. This is the results that we have shown. So basically, we have identified the flooding zone, and then we use the hospital information and to do some spatial analysis and to identify the hospital which is not in the flooding zone. And this is a quick example about AI assistance. So user can ask some kind of questions, do some queries such as show me all the COVID related data sets, and then it will show some relevant data sets as well, these kind of tools for the spatial interpolation analysis. And we have, so to make sure our resources are accessible and findable by other researchers, so we share all the resources, digital resources on Harvard Dataverse, including the datasets, components, or the tools and the case studies. So user can simply download the case studies and they can run the workflows on its own desktop without any configuration. All right, so a quick discussion. So in this project, we have developed a workflow management system supporting the FR principles and to ensure all the resources and workflow are findable, accessible, interoperable, and reusable. And we also offer an web-based intuitive graphic interface, enabling researchers at different levels to design and execute workflow with ease. But of course, there's some kind of limitation of the study's uncertainty or the hallucination of large language models. So this is something we will try to improve in the future. And we have published some preliminary results in this in JAG. So if you are interested in this work, just feel free to download this paper or reach out to me. Thank you so much.
Thank you. Do we have any questions? Can you hear me? Okay. Could you help me share this way? I know it's late. I know everybody wants to leave. We have another story, so we know we are not gonna tell all of those techniques, very heavy things. We're gonna tell a story about how we use generative AI to create a flood dashboard in Central Appalachia. So when we talk about a flooding event, the first thing came into mind is the coastal natural hazard, right? It's not. It's happening in Central Appalachia area as well, happening in the mountain area. This project, we got a ESEP Small Lab grant last year, and we aim to use generative AI to help with the data collection process, integration, and automate a dashboard that the community could use and serve for help the decision makers to make some judgment based on the data. We created a platform that serve all of this information. And we also tested with collected some community feedback and how we could improve that. And the study area is Central Appalachia, and we use the flooding case. Why? So it's increasingly common, and Central Appalachia, 82 counties, and Eastern Kentucky, we're talking about Eastern Kentucky a lot today, about the bourbon. and the West of Virginia, and southwest of Virginia, and northeast Tennessee, which I am located right now, Johnson City, as being particularly vulnerable. Late July 2022, it has a severe flash flooding, caused 43 fatalities and hundred of like houses, bridges are damaged. And Hurricane Helene, even though it didn't hit the central plateau a lot, it did hurt, like impact a very serious, cause a very serious damage in North Carolina and Tennessee, right? Annie, you're from that area. Do you still see a lot of damage in your area?
No, I live in Boston.
Oh, you live in Boston? Okay, do we have anyone who live in North Carolina right now? I know you, yes. Can you still see the damage there?
Not in my particular area, but yeah.
Okay.
I was talking to Douglas earlier, and he was like, oh yeah, they're still recovering.
Yes, and I live in Johnson City and I drive to Asheville. Yeah, right?
Yeah.
Let me see.
We live there in East Tennessee and can confirm there's still lingering effects from this.
Thank you so much. So every time I drive from East Tennessee to Asheville, and then the highway is they're still fixing the highway. Now we just have one lane from like each side. The traffic is still very bad, and you can see damaged bridges and everything is still recovering. And a lot of people died across those areas, and those are like very devastated, especially in rural and low income areas. So, okay, it's not working. Traditionally, we use GIS dashboard to host this information. I created a lot of GIS dashboard covering healthcare or natural hazard, air quality, and all of those require a lot of time and labor. And community engagement research also has becoming very impactful because we need to know what the community want and what the decision maker need to know. And if they can read it, they can understand what we're trying to deliver. Like they may not like the dashboard color, or they may even have color blind issues. We experience all of those questions, like issues every day. Like, I know this information exists, but I do not understand how to read this data. So we have to make sure it's user-friendly and it covers the topic they're interested in. And generative AI has a lot of capacities to advance those models. And Dr. Hu talked about is a large language model. I'm not going to talk more details about that. And the chain of thought, which we also used in our project, Launch and 2. And the 4 milestone of our project is first, automated flooding data collection and processing through GPT tools. The second one is prototype creation. So we created a flooding dashboard around January. And then we brought it to January ESEF meeting and collected a lot of feedback from the technical community members. And I also sent it to the Eastern Kentucky group, EMS people, emergency management people. And also sent it to North Carolina Dogwood Health Trust people because they are trying to do some hazard recovering, flooding recovering as well. And we're trying to see if this is something they want to see. And we recently finalized our GPT enhanced data pipeline and flooding dashboard, which we're gonna do a demo very quick. And this is a framework. People could ask some questions like, I live in Richmond, Kentucky. And do I need to buy a flood insurance? Or you can just specifically type your location, your street address. And you can ask, okay, where is the closest emergency shelter or closest hospital? And it will generate the route from your location to the closest hospital location. You could also visualize the flood map, and it will also generate the description about how to read the map, because not everyone has that knowledge or expertise to read the map, the flooding map, right? So that we also have that function. We have, this is like example, I'm currently living Stillwater, show me all mental health facilities within 50 kilometers, and the generative AI will separate it into different steps. Step 1 will identify, okay, I need to get the user's current location. Step 2, I'm gonna load all mental health facility data. And step 3, calculate and filter the distance based on the user's location and other criteria. And then generate the answer. This is how generative AI work in this case. And we had a prototype creation, which we showed in January. We have different tabs. The first left side is what this project is about. And on the right side, we have all different tabs to show the definition. We use the USGS data, water watch data set, file station. We also have other like waterways. We have a live traffic camera as well, because when something happens, some road are just damaged, you cannot use that road anymore. We also have characteristic data of the community. And this is some of the result we got from the community engagement work in January. General perception of the dashboard, they show very strong interest to synthesize, query, or translate multiple source data into one dashboard. Because instead of click all like 100 layers in the same map, they would be more interested in, okay, I just ask a specific question and they generate a map to answer my questions, right? And then concerns were raised by like LLM, the hallucinations, they mentioned that a lot. And also the standardized format and interoperability would be very interesting. Strength of the dashboard is very user-friendly. It's clear visualization, even for non-GIS users. It's easy to navigate. However, we could continue to think about like the layout consistency, which is a very big challenge right here. We use a lot of other websites too, like USGS, NOAA, NWS. They have all different type of format. And they have all the different ways to navigate it to get the information. It's very hard for us to make it consistent. And they want more metadata description, enable layer on one panel, and have some sign up alert for some area specific features. We're still developing some of those. Identify some gaps. Localized real-time data is very important. We heard the keynote speaker in the morning and talk about how important the real data is, right? Especially for natural hazard. And the use case promotion, we could suggest send it to EMS people, which we did, and we get some feedback, which is very interesting. One thing we got feedback is the fire station locations. The data we got, which is like official, it didn't cover all fire stations in Kentucky. And the EMS people sent it to us, and literally requires a local data instead of the nationalized data to make the data more accurate and more comprehensive. And it need to be relevant for the planning, preparedness. Also mentioned promote through ESIP clusters and generative AI in real world and policy contact to guide like action. Use generative AI for action guiding summary. Create conversations using digital twins, and all of those very good recommendations we got from January. So we're gonna do a quick demo of the dashboard. Can you see my screen for online?
Yes.
Well, I see
Okay,
I only see that.
oh, okay.
You need to exit the.
Share, screen, share. Is it working?
It is on Zoom, I think, but now we need to make it work on here. So you can
Yeah, we can see it.
Okay, we cannot.
Oh,
Thank you. Thank you. Can you still see it? Yeah. Okay, perfect. So this is our dashboard, flooding dashboard in Central Appalachia. And left start has some general description, and right side we have 20 tabs right now, covering generative AI dashboard, community profile. Community profile shows the community characteristic like population density, education, percentage of age group. It's kind of assessment of the need assessment. What if it happens? Do we have more older adults in that location? Do we have something different population composition, etc.? And then we have several tabs to show the flood hazard layer. We have the FEMA one here. We have USGS Water Watch too, and hydrology data set, each one. And the Water Watch shows, for example, Kentucky, high flow condition. It's real-time data. You can see it's current 7:30, pretty late. Fire stations, we recently updated to show all the fire stations in Kentucky and Central Appalachia. We also have flood inundation mapping service. And then we can see, here you have like river gauge, everything. Everyone has a different format though. I have live cameras, some of those are like waterways. We have a community characteristic like poverty rate of Central Appalachia areas, which one has persistent poverty. And we also have the percentage of poverty rate. We have labor force participation, hospitals, and we also have a documentation for all variables we have here, and link to the description, data source, geographic level, contact information. And one thing I want to highlight here, and I do want Dr. Hu to do a demo about our generative AI enhanced flooding dashboard part. Can he share his screen? Okay.
can you see my screen?
Not, yes.
All right. Yeah, so this is a kind of demo to demonstrate how generative AI can be used for this case study, especially the flooding dashboard in Central Appalachia. And here I want to give maybe give 4 quick questions, or 4 or 5, and to show how it works in this dashboard. So the first one, is where is the Central Appalachia on the map? So basically, you see, when I type this question, and then it will process the question, and we have execution logs. So it shows how the train of thought works in the in the back, and we also, as you see, so here this is the boundary, shows the boundary of the Central Appalachia. And here we also have some sample questions here for you to use. And second question that I'm kind of interested in to know in the disaster is to understand for example, how do I get to the nearest hospital from my city, Yankins, KY, Kentucky? So basically, we have incorporate the hospital information and understand and do the geocoding based on location of city. And then it has conducted the routing analysis to find out the route from the city to the nearest hospital. So this is the route showing this Yankee City to nearest hospitals. Of course, we can also show the all hospital, but I didn't do that today here. And so next question that I want to know is which counties in Kentucky have the most elder population or adults? Yeah, this is a really critical because during when disaster came, so we want to understand where are the vulnerable population located. So and here, so we can extract data from the CDC, which include the social vulnerability index, and we extract all the data sets and conduct analysis. And so this is a response. Kentucky are counties with the highest percentage of elder population residents as Robinson, Cumberland, Green, and Menifee. And the next one, I'm pretty interested to see the flood map and how, especially the flood risk of a place. For example, I can ask question like, can I see a flood risk map of Yankins, Kentucky? And then we will, actually the data source is provided by the FEMA. So FEMA has a web service showing the flood risk map. And in this dashboard, we use not only take advantage of large language models, we also use the visual language model, and actually provided by OpenAI. So it can help us to understand, to interpret the map. Because for some users, even though we can, the FEMA has provided the map. However, it is really difficult for users without any kind of prior mapping skills to understand the map, to interpret the map. So therefore, we retrieve the map data from the FEMA, and at the same time, it helps us to interpret and explain the map and to identify the regions with a higher risk of flooding. It could be a little bit slow because we try to access and download datasets and do some analysis. Let me see. So it is in the process, and it's still in process. Try to interpret. All right, so we got a response. And you see, so first we can download the original, the flood map. So this is requested from FEMA. And this is original PNG file. This is a flood map. So this is the original, the flood risk map. All right.
We cannot see the flood map.
Oh, okay. Sorry, let me stop sharing. I should share the whole screen. Okay, can you see now?
Yes.
Okay, so this is the flood map downloaded from FEMA. Request, yeah. And it has like this kind of map, and it shows like the regions with a high risk of flooding, and these common explanations of the map. And so, however, as I just mentioned, some users may have limited experience of reading map. And then here we do give some kind of explanations. So for example, this is the flooding zones. So we have a flooding zone A, E, and these areas are shown in the blue, indicating these are within 1% of annual chance flooding pain, also known as 100-year flooding zone. So these areas are subject to flooding hazard and require flood insurance. And similarly, we can have other information for zone X, and we have an explanation for the flooding map and flood weight and base flood evaluation, so on and so forth. And there's some other usage information. All right, I believe so based on this kind of, this is still kind of a demo. So we are trying to improve and do some more evaluations and validation of response from the generative AI. So that's why we hope we can get some kind of response from you in this session, so we can help improve the dashboard.
Thank you. Yeah, so let me reshare the screen. Do we have any questions, comment? Yes? Oh, yeah, sure.
Hi, I just came in. Is this on? Now it's on. Okay, I just came in at the end of the talk here, but looking at the flood map you have, I would encourage you all, just based on some of the talks we had earlier, I would encourage you all to reach out to the Kentucky Division of Water. And I can probably give you some contact names, but they are working on, updating firm flood-related data. And I would just encourage you to reach out, because I hate seeing duplicative effort. So that's all.
Thank you. We will definitely do. We have one person online has question. Zach,
Yes, I have a question about the dashboard, or an
Yeah.
idea. I really like the dashboard. It looks really cool. And I saw there was an option for sample questions. Do you think it'd be useful to have some guidelines for user prompts?
What do you mean guidelines? So
Saying, for example, basic guidelines on how you would structure a question, like saying you'd want to give specific location information or
exactly.
something like that.
Yeah. That's very helpful. Yeah, we just show some kind of the vague maybe locations and give more. Yeah, not a specific ones. Yeah. Thanks.
Awesome.
thank you. Yeah.
Yeah, I can jump in. I'm Anthony Boyd. I'm with Development Seed. And so we've been working on some similar flood dashboards. And I think one of the challenges that we run into is how to make this information accessible for people who need it in real time. And it sounded like that's, just based on the pitch that you gave at the beginning, that's an area that you're trying to get into. It was interesting then to see, which is a problem that I think a lot of us struggle with, that then the demographics that I saw in your feedback session
Yeah.
was very much not that group. So I'm curious, like, with that in mind, what do you think you need to do to what you've shown us so far to make it more valuable for people on the ground who are experiencing a flood in real time?
Yeah, that's a great question. So we are trying to do some promotions with the emergency management people, because they're like the first responders when something happens. And also they are trying to distribute this software tools to their community and their people as well. So we're still keep getting feedback from them, what could be useful, and we really wanted to include all the real-time data, which is super challenging. And we also welcome all suggestions. If you have someone in your mind who we should contact, and there any better way, better data source we could use to keep track on the real-time data, we're happy to take that and include it in our dashboard. Other questions? Yes. Yes. It's okay. No, you should not. You should definitely tell us.
Oh, yes. So I understood also early in the presentation that
Yeah.
open source is really important. And I wasn't sure if
Yes.
that was specifically for data or if that also related to software, but I noticed the dashboard that you shared was with ArcGIS and Esri. So I'm curious if you could talk us through that decision.
That's a great question. So the reason why I use ArcGIS is I developed a lot of different dashboard, and I think Esri is pretty user friendly, and it's we have like enough credits to support all the development of the thing, and it's completely free for the rest of the community. It just charge like more money and the resources, and we do want to develop a user-friendly, easy to navigate product to the community. Yeah. I don't know if you're happy with that, but it's pretty challenging. More questions?
No, I know it's a challenge. We build a lot of alternative tools for startups, so
Yeah.
I'm just curious to hear.
Yes, definitely, like, I'll definitely, like, support all open data thing, but sometimes, Esri is pretty, like, they have developed a lot of good function that maybe other software do not have it at this time. I do hope other, open source data or software could have more resources and share all of those data and things in the future. And Zach, you have another question? Hey.
Yes, me again. Sorry. This might be a weirdly specific question. So for the dashboard, for the knowledge corpora that you use for it, how do you keep the knowledge corpora up to date?
Knowledge what?
Oh, knowledge corpora, sorry. So the documents that are being fed to the model or that the model uses to produce the response.
Oh, is that a Dr. Who's question? Or do you want to answer that?
Yeah, I can. So it depends on the data sources. So for example, for the CDC or Census Bureau, the census data, the most recent data we can get is maybe the annual level. So we are not able to get the most recent data sets or real-time data sets. And we know that, of course, the real-time information is pretty critical and for like later hazard mitigation and response. But at the same time, for a remote sensing image, we also have some satellite with a different spatial and temporal resolution. We just try our best to get I think the current step is to get the most helpful and useful information. This is most important thing. And the second one is about like the time the time of the information. If it is we can get like real time, that'll be a great plus, addition.
So do you just upload the knowledge base every once in a while, or do you have an API that calls a certain data source?
Yeah, currently actually the data set is kind of static. We just
okay.
download data sets from local and saving it, and in the future we try to involve more data sets. So in that case we can and we also if we want to incorporate more data sources, we also want to provide using the data service, the web service, to get real-time data. Yeah, so it depends on the availability of data source. Yeah.
Okay, excellent. Thank you.
Mm-hmm.
Do you have questions? I thought you raised your hand before. Yeah, you.
It's great. Thank you so much for a wonderful presentation. So, I'm curious about the Gen AI part. I believe you're using S3 Geo AI plugin or something. Is that right, or it's something you developed your own?
The dashboard is the platform, overall platform is on Esri ArcGIS Online. But the generative AI is not a part of that. Dr. Hu could better understand where
Yeah, so actually, so we just attach the link to the ArcGIS story map. It's a story map, all right? So it's
Okay, yeah.
attach that web page and deploy everything in Amazon, in AWS. Yeah.
Yeah, because I attend the S3 Geos Design Summit this year. It seems that they have this kind of function for you to use. It's kind of integrated with S3 platform. So since you are using S3 platform to create dashboard, maybe that will be much easier for you to use the tool. Yeah, but it's great work. Yeah, just a suggestion.
Thank you.
Yeah, thanks.
Thank you.
Yeah, we will figure it out. Yeah, later. Yeah.
Any other questions? I love this session. It's so late and everybody is still very engaged. Thank you so much. Okay, we do have breakout questions. I know we only have 14 minutes, but we are really interested in, okay, technology, yay. Yeah, okay. I'm not touching it. Share? Share? You didn't share. Great, okay. We do have a lot of questions, but we're only gonna talk about, since we only have this many people, how about we just pick 2 questions here and 2 questions online? Dr. Hu, could you pick the question 3 and 4 for the online group? Probably 2 breakout group. And then for in-person, we're gonna only talk about the first 2 questions. So how about 4 people each group talk about 1 question? Like this group talk about question 1 and this group talk about question 2. Does that work? Or just 3 people that work too? The first one, from what you've saying, how could this kind of dashboard actually help in your day-to-day work or local planning decisions? It could from different data provider perspective, policymaker perspective, and another thing you could do, the second question it discusses based on those functions we just showed, what excites you most or worries you most about using AI for those type of analysis? Is that okay? We're gonna do maybe a 6 minutes or 8 minutes discussion and have a short reflection, and then we'll end up our day. You can go to baseball game or, right, or dinner, something. Okay, do we want to do some reflection right now? I know it's a pretty short time discussion. I'm so sorry. Do we want to start with group 1? Who want to get some reflection we have discussed, maybe?
You mean online or?
No, we have in-person group.
Okay.
We were talking about kind of like short-term disaster response and long-term like risk planning as kind of like
I love that.
2 objectives that
Yeah.
policymakers have.
Yeah.
Most of what we saw here mostly fell into the latter category. These seemed like more a presentation of socioeconomic factors that may drive like inequities among neighborhoods. So as far as like planning decisions, it would be like really long time horizons.
Yeah, I like that. Thank you. I mean, we want to cover both, but it's very difficult, especially like every data provider provide different type of data, and it's hard to put them together and provide a real-time monitoring and alert thing. Thank you. Really appreciate that. Group 2?
Group 2. Our question was, what excites you or what worries you most? We talked a lot about is the short-term disaster response need, and there's, I think, a lot of concern about generative AI being used in that application. just creating a barrier to useful information, and also like the trust factor
Yeah.
of it's a robot, it's not
Yeah.
a robot, but also is probably more accurate than humans. I think one of the things that excited us was maybe more in the long-term planning,
Yeah.
in that, especially with where AI could go in the future, the agentic AI,
Yeah.
and just overall advancements, that it could become really powerful. And I think like we're already seeing stuff like that from Esri, and lots of other open source solutions, to throw that out there again. But that's, I think, where I sense the most excitement.
Thank you. Really appreciate that. Online group?
Yeah, actually, so we just quick have a discussion about the third question. So what makes you feel more confident about trusting generative AI by mobile decision making? And we have mentioned several things. The first thing is about like we need to have our models well trained, so they can be trusted by the local users. And the second one, is the transparency. So we need to, it would be better if the models or the AI tools can link to the resource they leverage. And as well as some other, it's not just about the data, as well as maybe some kind of tool and maybe the processes. So it can help us to build like trusties and confidence when using the generative AI. And one more thing I think from my perspective is that we need a more like evaluations or standards like or metrics to make sure like the results generated by the AI can be trusted. So the metrics it will be long term. It's not just a one single point like evaluation, but will be the evaluation over time, because sometimes the AI get stupid. As you know, some like ChatGPT at the beginning is very smart. However, when it is upgraded to the new version, actually it's not as smart as before. So because there was a kind of further some more data training and maybe some other things. So that's why we need a like a long-term evaluation, not just one single point evaluation to make sure the results are trusted.
Yeah, that's that's definitely all of those very important point. And one thing that reminds me to talk about is I'm thinking about the regulation of how to using generative AI, and all the AI is at the policy level, like the national policy level, how to use it, and for if we invest more money to do it, what's the regulation we need to obey when we develop those, when we use those. And for academia people, how we could use this, and for industry, and at different maybe local level, state level, national level, each level need to have specific regulation for how maybe definitely still need a human involvement in this, because we do have some trust development we're still working on. But great discussion. I'm sorry I stole 2 extra minutes of your evening. Okay, so thank you again for being here today and had a wonderful discussion. Really appreciate that. Thank you so much. I will see you around. Have a wonderful evening.